So the first thing to say is that I started looking at this area many years ago. And being Scottish, and at the time Scotland had the highest rate of heart disease in the world, at least that's what we were told. I'm not sure that's true, but it was a very high rate. I thought, well, what's going on here? And I started looking into the area and became aware very rapidly that it wasn't making sense. The cholesterol saturated fat hypothesis, everybody says that in Scotland all we do is eat deep fried Mars bars. What I have to say is a deep fried Mars bar is almost entirely carbohydrate anyway. So why would that have anything to do with saturated fat? A Mars bar has almost no fat in it. But a very interesting study came out. This is sometime after I was interested in it and started to believe that cholesterol had nothing to do with heart disease. It's called the Scottish Heart Health Study, and because it was done in Scotland, it's the best study ever done in the world. Jimmy. And it looks a bit complicated. A lot of my graphs do look a bit complicated because I don't like simplistic answers. Now, what this is looking at is all deaths in men from heart disease and the things that are risk factors for it. A comparison of prediction by 27 factors of coronary heart disease. If you actually count this, there's 26. So I don't know what happened to the 27th. It's obviously fallen off the bottom of the page. Now, you might think there's another thing to put in. A plus means it's a risk factor and a minus means it's protective. All right? So the most important risk factor for dying of heart attack is having had a previous heart attack. Well, that's not exactly surprising, and it doesn't really tell us anything. That says you've already got severe heart disease and have had a heart attack. Interestingly, the second most important factor is plasma fibrinogen. And I don't know how many people here have even heard of fibrinogen or know what it is. It's a blood clotting factor. And this is very interesting because this has been found again and again and again and never mentioned to anyone ever. So you will never have heard of this, but I've seen it in hundreds, thousands of research papers because it happens to be what I'm interested in. Serum creatinine, by the way, is just a measure of are you a smoker. It's just a blood test measurement that doctors do. If someone says I've stopped smoking, they might measure it and go, no, you haven't. So now you know. They don't think they do that anymore. Smoking cigarettes, which is sort of the same risk factor. Now here's an interesting one. Serum potassium, negative, i.e. protective, i.e. very protective. So the more potassium you excrete, i.e. eat, the more you are protected against heart disease. Now once again, you'll never have heard of this anywhere ever, but I have found this to be a very strong protective factor against dying of heart disease in any study I have ever seen. So eat your broccoli, or whatever it is that's got potassium in it, which I can't remember. Interestingly, well, diabetes is quite a strong risk factor for dying of heart disease, but you'll notice a very interesting factor is that your blood sugar level is not. Now this is another consistent finding that people can't understand. I'm not going to go into that this evening, but it's an area I'm very interested in. Leisure inactive means people who don't take exercise. Now that is damaging. Housing tenure, that means do you buy or rent a house? People who rented houses are more likely to die, so that's really a social factor. Systolic blood pressure was a risk factor, and urine sodium was quite protective. 50% reduction in dying of heart disease if you had a high sodium level, i.e. ate more salt. So another area I'm particularly interested in is that salt is good for you, eat more of it. Bortner score, now this, I'm not going to go into this in too much detail, is actually a score of stress, but it was for type A personality. Now interestingly, this was apparently protective to be a type A personality in Scotland, which probably just means you're a type A alpha male that beats up all the sort of weak, pathetic ones. I'm not going to go into that here, but it is interesting. Tocopherol is just a vitamin of some sort that people thought were important, but isn't very important. And when we start moving down the list, non-NS means not significant, NL means non-linear. In other words, the risk goes up and down, and it means nothing. So, HDL cholesterol, not significant. Triglycerides, not linear. Ascorbic acid, which is vitamin C, not significant. Alcohol, not significant. Uric acid, not significant. Total cholesterol, not significant. Weight, not significant. Another vitamin, not significant. Energy intake, not significant. Body mass index, not significant. Blood glucose, not linear, not significant. So almost everything that we are told causes heart disease can be found here. And you might say, well, this is just one study, it's just in Scotland, and who cares? What I'd say to you is, I can find you these results from every other study that I've seen. There is nothing to contradict this. You might think there is, but there isn't. These ones up here are very interesting to me. Fibrinogen, potassium. I know everybody knows that smoking is bad for you, and this just confirms that. I'm not going to say smoking is good for you, which is about the only non-controversial thing I happen to believe in, I think. So that was one of my key contradictions, and I'm looking at 10 key contradictions. My second key contradiction, this is a study done in Norway over 15 years on 50,000 people, and it looked at your risk of dying of cardiovascular disease. It was called ischemic heart disease. I'm sorry, the terminology is horrible in this area. IHD means ischemic heart disease, means coronary heart disease, means what you would call a heart attack. It's the same thing essentially, myocardial infarction. And it looks at men and women, and it looks at the hazard ratio. Now, a hazard ratio of 1 means you are at average risk of dying, 0.8 means 20% less risk, 0.6 means 40% less risk, and that means 20% more risk, 40% more risk, etc. Does that make sense, or have I done that too quickly? So they set the risk at being of 1, which is just a statistical thing you can do, when your cholesterol level, total cholesterol level, was less than 5, which is about lower than the average in the UK and in Norway. If your cholesterol level is between 5 and 5.9, at which point nowadays you'd be straight put on a statin, your risk of dying of heart disease as a woman went down 40%. Stayed 40% lower, and was still lower even when your total cholesterol was above 7, which is what people nowadays would call familial hypercholesterolemia. In men, the pattern wasn't exactly the same. If you're wondering what these strange bar graphs are, these are the confidence intervals, which, as you can see, do cross 1, which means the statistical significance is not strong. But interestingly, effectively, as your cholesterol level goes up as a woman, you're less likely to die of heart disease. And that's 50,000 people, 15 years. Study called Hunt 2. The study authors wrote to me and said, could you please publicise our study? Because they had heard of me and my convictions about cholesterol. Now you might say that's one study. Well, I'll tell you about another study which is called Framingham. The Framingham study, which you may have heard of, done in the United States in a town called Framingham, set up in 1948. It's near Boston. And they looked at all the things that might cause heart disease, and they measured them. And one of the things they came out with, they said that high cholesterol level was a risk factor for heart disease. Interestingly, that study, it's been going on for years, it's still going on. Now, a little bit more background is that after about 1990, people started getting put on statins, so you can't really look at what happened after that because cholesterol levels were all over the place. But what they found was, if in the first 14 years of that study, your cholesterol level fell by 1 millimole per litre European levels, during the next 18 years of the study, your risk of heart disease increased 530%. Now that was never published anywhere. I happen to know about it because a chap called George Mann, who ran the study, who since running the study has called the cholesterol hypothesis the greatest scam in the history of medicine, revealed those data to some other people. Another contradiction I like to point out is Japan, which has got a very low rate of heart disease, always has done, despite the fact they smoke like chimneys. Now, if you go back to 1950s, 1960s, they ate very little fat, they ate very much carbohydrates. The fat consumption in the last 50 years in Japan has increased 400%, saturated fat by 200%. So you'd expect, wouldn't you, that the cholesterol levels went up? Well, they did, from 3.9 on average to 5.1. 5.1 is a bit less than the average in Britain currently. So what happened to their rate of heart disease? Well, it fell 60%. And what happened to the rate of stroke? Well, I can't say it fell by 1%, because once you start going over 100%, you can't use percent falls. It's not statistically valid. It fell 7-fold. So it was about 1,200 deaths per 100,000 per year. It is now around about 200. So it is basically fallen. And an interesting fact that nobody knows this when you speak to them is that Japanese were so worried by their high stroke rate, and their strokes were primarily hemorrhagic. And if you don't know, there's two sorts of stroke. It's hemorrhagic, where you bleed into your brain, which are usually a worse form of stroke, and an ischemic stroke, where a clot blocks in an artery in your vein, and these are two completely different mechanisms. Hemorrhagic stroke was the thing that killed the Japanese. They were told to eat saturated fat to raise their cholesterol levels to stop them dying of stroke. So they ate saturated fat, their cholesterol levels went up and their rate of stroke fell, I will say 700%, because it's quite a nice big figure, although it's not statistically valid to say so. So that's quite a strong piece of evidence, I would suggest, that saturated fat, cholesterol, fat, whatever you want to call it, is good for you and prevents heart disease. Here's my fourth contradiction. I decided on 10 contradictions. I could have given you 30, but these are the 10 I decided on for the sake of this. Now, this was a study done in America. They looked at 231,986 hospitalizations from 541 hospitals, which is a lot of people. And eventually they found that the lipid levels, i.e. the cholesterol level, they call it, when they want to hide what they found, they call it lipid, not cholesterol. Because if they called it cholesterol, then you would think, oh, look what they found in 60%. So 137,000 people had their cholesterol level measured when they arrived at hospital, having had a heart attack. So that should give you a good indication of what the average cholesterol level is in people having heart attacks. And the mean LDL levels, and unfortunately America uses a different form of measurement. They use milligrams per deciliter, which you have to divide by 38.579 in order to get the UK and European level, which is 2.6. Now, I don't know if anyone knows what your LDL level is. That's actually quite low. American Heart Journal, 2009. This is the graph of the cholesterol levels or LDL cholesterol level. LDL is not your total cholesterol level. I'm sorry. Again, it's the LDL is known as bad cholesterol. You may have heard this. HDL is known as good cholesterol. How scientific is this? Because good cholesterol is nice and it's fluffy and it's lovely and it gives money to charity. And of course, cholesterol is just cholesterol. Cholesterol has a chemical formula. It is a chemical. It doesn't change its structure. Cholesterol is found within lipoproteins, but they call it cholesterol anyway. And then they call VLDL, which is very low density lipoprotein, they call them triglycerides, just to throw you further off the scent, so that you have no idea what anyone's talking about at any given time. And then they talk about light, fluffy LDL and particle sizes of LDL. You might have heard all this rubbish coming out recently. Let's just keep changing the goalposts. I mean, if once you've contradicted them, you just suddenly find, oh, well, we weren't talking about that after all. It was nothing to do with that. It's particle size. What are you talking about? Oh, stop doing this to me. Anyway, I thought what I would do is work out what the mean LDL levels were in the US during the time of this study. Quite a difficult thing to find out. You'd think that would be quite easy to find out. It's quite easy to find out in other countries, but in America it's just hidden. That is the mean or average low density lipoprotein bad cholesterol level in the year 2006 when this study was done, right? 125 or 126, I think it was. As you can see, 78% of people who had a heart attack had an LDL level that was lower than the average. What does that tell you? Well, what it tells me is people with low cholesterol levels are more likely to die of heart disease. And that's what you think anybody would sort of think from this, wouldn't you? The conclusion of the authors of this study was, well, it's clear we're not getting the LDL levels down low enough. This was the conclusion of this study, which is to take reality and stomp the living daylight out. It's just nonsense. What amazes me is there are people here who've got an LDL level of 20. 20! I mean, I don't think that's compatible with life. And they're still having heart attacks. Now you might say, oh, there weren't very many of them, but I'll tell you what, I bet there's less people with a percentage LDL of that than there were having heart attacks, by a factor of about 20. If they're saying that LDL causes heart disease, how on earth can people with a level of 20, which would be 0.7, that would be an LDL level of 0.7, right? I've never met anyone with an LDL level that low. There is a condition called Smith-Opitz-Levy syndrome, where you don't produce enough cholesterol in the womb, and children born with this syndrome die due to a lack of cholesterol levels. Their brains don't form, their nervous systems don't work, and they die. So actually, these people here, I don't know how they were still alive, but they were, apparently. Which brings us to another thing, familial hypercholesterolemia. Now everyone tells me that familial hypercholesterolemia causes heart disease, and I say to them, No, it doesn't. It's one of the more controversial things that I say. One of the problems that you have is that when people arrive in hospital, then they have a high cholesterol level and they have a heart attack. What they immediately do is they go around all their relatives and go, oh, what's your cholesterol level? Well, unsurprisingly, a lot of them have got a high cholesterol level. And the rate of heart disease in that family is often quite high as well. Now, what they could have said is, well, how many of you also got red hair? What you don't know, there is a huge problem with doing a study this way, is that you've already selecting a population with both high cholesterol levels and a high risk of heart disease. And it could be there's another factor, C, that is causing both, that is associated with that genetic system. Now, people look at you and go, I use this analogy that people with yellow fingers are more likely to die of lung cancer. Well, of course they are, because they smoke. Does that mean if you scrubbed their fingers clean that they would not get lung cancer? Does it mean having yellow fingers causes lung cancer? No. That's called a confounding variable. Now, in the familial hypercholesterolemia research, there is this huge confounding variable. They find people with heart disease who've got familial hypercholesterolemia and say it's the familial hypercholesterolemia that causes the heart disease, because lots of people in your family have got heart disease. You cannot say this. But here's a study that was done in 1996, prior to all the statin nonsense. What they found is there's no evidence that familial hypercholesterolemia shortens the life of affected individuals. On the contrary, they show that high levels of serum cholesterol are clearly compatible with survival into the 7th and 8th decades. You don't die of this disease. Now, this has been shown again and again. People with familial hypercholesterolemia are, in some studies, more likely to die of heart disease. They are less likely to die of cancer and infectious diseases. The average life expectancy of people with familial hypercholesterolemia is essentially identical to that of the surrounding population. So here's a disease that has no symptoms and causes you to live as long as you would have if you didn't have it. I don't call that a disease. I call that just having a slightly different level of something in your blood. But, and this study was never published, and I only found out about it from somebody else who pointed me in the right direction. This is the same thing with familial hypercholesterolemia, because what these people did was they turned the question around through 180 degrees, and I'm sorry, this does require a bit of explanation. Because of that confounding factor thing that I talked about, what they decided to do was to first of all ask people, do you have anyone in your family, like first degree relative like father, who has had a heart attack before the age of 55, all right? In other words, we're doing this study the other way around. We're first of all finding out people with heart disease. Then what we're going to do is we're going to find out how many of these people have familial hypercholesterolemia, how many of the sons have familial hypercholesterolemia. This way you're getting rid of the confounding variables. Does that make sense to people? Does that make sense? So although the results actually have to be explained, so this is the European Association of European Atherosclerosis Research Society, which is very much into familial hypercholesterolemia. So they found students whose fathers had proven heart disease before the age of 55. They were recruited. Age and sex match controls were recruited from the same population for each case. Now we're talking here 1 in 500 people will have a relative with proven death from heart disease before the age of 55. So this is a very large population of people, although it ends up being a small population. So what they found was that 2 of the 1,089 students with a family history of coronary heart disease had familial hypercholesterolemia. Right? Now, obviously, in order to find 1,089 students, a father with heart disease at that age, they had to ask about 100,000. All right? So this is a big study. It's not a small study, it's a huge study. 4 of the 1,727 controls had FH. Now what does that show you? What does that state to you? It states that the prevalence of familial hypercholesterolemia in both groups, those who have a family history and those who don't have a family history, was not significantly different at approximately 1 in 500, which is the estimated prevalence of this condition in the general population. So what does that prove to you? It proves that familial hypercholesterolemia does not cause heart disease. Thank you. This is the only study that this has ever been done. It was not published. And in that there is obviously a whole tale in what is and what isn't published in research. The fact this was not published is worrying. The author of a letter in the BMJ, somebody finally did write about this, he was from Glasgow and I spoke to him. The evidence that heterozygous familial hypercholesterolemia is of itself a cause of atherosclerosis is unsatisfactory. And that's a scientific way of saying it doesn't cause it. And I'll bet none of you knew that before you came here tonight. If you want to, I've given you a reference. You can go and look it up yourself. So, familial hypercholesterolemia is not a cause of heart disease, which kind of contradicts the hypothesis. Here's one of my favourite graphs, in only that it comes from a very conventional study called the Monitoring, I can't remember what it stands for. It was done by the WHO anyway, and it's a huge study across Europe, across 32 countries, looking at the factors that cause heart disease in these countries. So here's a look at heart disease rates in different countries. This is going back to the study in 2008. And as you can see, there's Spain pretty low, France pretty low. I think Bosnia didn't have any results because they were in the middle of a war. Ukraine, Russian Federation, I can't remember which one of these, Latvia, that might be Lithuania, I don't know. Belarus, Ukraine, Moldova, I don't know. My geography's not that good. Kazakhstan, Turkmenistan, all the other stands. Anyway, basically, if you move from east to west, the heart disease rate goes horribly far down. Britain is a wee bit of an exception, as we've got a sort of medium rate here. France, Portugal, Spain, whatever, basically very low rates of heart disease. And then they looked at energy from fat in the diet, and this is like, you know, in Doctor Who when the Daleks exterminate you and the black goes white and white goes black. This is energy from fat in the diet. And as we can see, it's the exact opposite. The exact opposite. Here we are, all these countries. Country with the highest saturated fat intake in Europe, France. Country with the lowest rate of heart disease in Europe, France. Country with the lowest intake of fat at that time in Europe, Ukraine. Country with the highest rate of heart disease in Europe, Ukraine. I mean, yes, you can't use these figures because there are other factors. People say, well, there's other factors involved. You can't just look at one country. I said, well, Ansel Keys did that and proved that saturated fat causes heart disease. But I can show you figures exactly the opposite. And you say, oh, you can't prove the opposite. Well, you can actually. Epidemiologically, an association does not mean a cause necessarily. But a lack of association means it's not a cause. That's science, right? That's very simple. Science, page 1. So, energy from fat in the diet and energy from saturated fat are very much the same. Now, what I noticed recently, and I did blog about it, was the figures from 2008 had saturated fat in them. The most recent research from 2012, the information on saturated fat has gone. It no longer exists. So, we're getting a nice rewriting of history going on now as well. In that once you get research that doesn't agree with what you want it to find, you just don't publish it anymore. And you can see this on www.heartstats.org, which you can actually find on the British Heart Foundation website, which is interesting because no one has obviously ever looked at their own statistics, otherwise they wouldn't come out with the absolute nonsense that they do. Here's a nice contradiction. I like this one. This is from Japan and Russia. And it's quite difficult to compare countries actually because they don't provide you with the same data from different countries. They deliberately don't do this. So you can find all sorts of things, but you can't compare. But I did manage to compare as much as was possible. Now, the major risk factors for heart disease are considered to be age. That's true. As you get older, you're more likely to die of heart disease. Sex. Men are more likely to die at a younger age than women. That's true. But two of these factors are obviously irrelevant because this is looking at the rate of heart disease per 100,000 per year in men under the age of 65. So it's exactly the same male age population. So those factors are gone. What are the other factors? If you've been to your doctor and they say, oh, we're going to measure your blood pressure, have you got diabetes, all right? What's your cholesterol level? Do you smoke? These are the other ones. So these are all the factors that they're going to say, or you're going to be looking at to tell you what your risk of dying of heart disease is in the next 5 years, which is, of course, complete nonsense. Japan, average systolic blood pressure in men 135, Russia 124. Right, so it's lower in Russia. Rate of smoking 45.5% versus 47%, pretty much the same. Saturated fat intake very slightly higher in Russia. Cholesterol levels exactly the same. So all the risk factors, the important conventional risk factors for these two populations are the same. So you would expect the rate of heart disease would be about the same. Otherwise, the risk calculators are nonsense, are they not? Well, as you can see yourself, here's the rate of CHD in Japan, 15. Here it is in Russia, 267. Now, we're not talking 10% here, we're not talking 20% here, we're not talking 100%, we're not talking 1,000%. No, ladies and gentlemen, I haven't actually worked it out. We are talking 1,800%, 1,827%, I don't know. That is such a gigantic and enormous difference. All risk factors are there. You go to your doctor, those are the ones they'll measure. They won't measure anything else. And they'll say your risk in the next 5 years is whatever it is, some ridiculous figure. No. Well, where did the gap of 18 come from? Where does it come from? Well, clearly, none of these things have anything to do with heart disease, or very little to do with heart disease, because otherwise you wouldn't get people not dying of heart disease here. We're told smoking is a very high risk factor for heart disease. The Japanese don't get heart disease. Interesting, is it not? Neither do the Mexicans, by the way. But a lot of countries, smoking is a very major risk factor. Why is this? Well, it's another total new story. Here's another thing that I did from the figures from the Monica study. I looked at saturated fat intake, death rates from heart disease, and cholesterol levels. In some countries, cholesterol levels are not available. In Georgia, 5.2% fat intake, heart disease rate 235. France, 15.5%, death rate 24. Cholesterol level, obviously, here 5.9. Cholesterol level in Russia, 5.1. Heart disease death rate, 267. These figures you cannot look at these figures and say the saturated fat in the heart, in the diet or cholesterol levels have anything whatsoever to do with heart disease. Look at this one down here, interests me. Switzerland, 6.4 millimoles per litre on average. That would mean every single one of them is on a statin now. Heart disease rate 32, about a quarter of that in the UK. These are not my figures, these figures come from the World Health Organization. You can go and look at them on the British Heart Foundation website, and they're, apart from the saturated fat, which have been made to disappear, the rest of them are there. For this one, contradiction 9, I'm thankful to Zoe Harcombe, who's a Fellows cholesterol skeptic, who looked at all the countries in the world, which is quite a difficult thing to do. Looked at the cholesterol level in all the countries in the world that have any such data in women, and then looked at the rate of heart disease in all the countries in the world relative to the cholesterol level. And then she put one of these little association lines on, which you can do mathematically. There's a lot of dots all over the place, obviously. But essentially, on average, in the countries, as your cholesterol level went up, the rate of heart disease went down. And that's data from the entire world. So you can't argue with that. Same for men. It's a lot. The line for men is a bit more like that, but it's still negative, right? So in other words, if you have a high cholesterol level, you don't die of heart disease. Or if you have a high cholesterol level, you don't die of heart disease. I've been incorporated. The meme has got into my brain as well. And the final study I'd like to look at, a study you'll never have heard of again. There's quite a lot of words here. 67,413 men and 82,237 women, which is a lot of people. And they were aged from 20 to 95, underwent 454,000 examinations. So this is not a to be sniffed at study. It included measurements of blood pressure, height, weight, and fasting samples for cholesterol, triglycerides, gamma glutamyl transferase, and glucose in a 15-year period. The one I'm interested in is this one. Low cholesterol was significantly associated with all-cause mortality. In other words, the lower your cholesterol was, the more likely you were to die. And that was at all ages from 20 to 95, showing significant associations with death through cancer, liver disease, and mental diseases. In other words, you were much more likely to die of cancer, liver disease, and mental diseases. I'm sorry, I don't know what the mental diseases were. I think believing that cholesterol causes heart disease is clearly one of them. Now, I could keep giving you this stuff all night. I'm just giving you 10 of these, all right? You're either convinced or you're not that there must be something amiss if these figures are correct. And these figures are correct. And anyone wants to... This, by the way, was a study called Why Adam Isn't Eve. It was done in Austria. It was published in no journal you've ever heard of because they wouldn't accept it. But it was published in a peer-reviewed journal.